welcome back. Today we have live stream number 17. So yeah, those numbers go up fast. I guess soon I will need to stop counting because it is kind of pointless, right? All right, so agenda for today. First I'm gonna say thank you for watching. Remember to like and subscribe and follow on Twitch. Feel free to ask questions in the chat. Feel free to ask questions, in the comments under the video after it's been finished. I'm always happy to respond. So that's that. And next thing will be I will have shout out to one of the viewer. Then I'm gonna go through a little bit of a tutorial like we used to when we're learning them. And after that, we'll just jump into commonFs. I'll show what I changed because I changed a lot actually. And I'm gonna continue fighting with writing the files and all this stuff. Hopefully it's gonna go a little bit smoother than last time. So let me just open up a browser. And I'm gonna show you what one of the viewers, to be exact, where is it? There we go. Not that. GitHub.com. Alrighty. So, on Monday, we were coding a little countdown timer that you saw when the stream was starting. And one of the viewers, the Drunken Alcoholic, actually submitted a PR out of nowhere, making all the numbers much nicer, much cleaner. So thank you for that. On top of which he added colors, so we have some fun colors. Maybe one time we're gonna add some configuration to them, or maybe add some kind of different way to post a different message, because when the stream is starting and it shows Ben will be back, it's kind of doesn't make sense. It would be nice to show, I know, stream will start in or something. So that's that. Let me actually hit record on the in OBS. Okay, cool. So that's that. And yeah, big shout out to Drunk Alcoholic. Thank you for that. And just to show quickly the changes, if somebody didn't see. Let's go cd repos. Let me just zoom in a little bit. Streaming utils and countdown, so we can do nimble run, and let's say 15 minutes. We have nice full characters now, so that's very fancy. And we have blue color, and here we have I don't know, pink color, violet color, something of that sort. So again, thank you. So that's when it comes to the shout out. Next topic. Yeah, we need to go through the tutorials. So let's close all those things. I just have lots of stuff that I don't need right now. So let's go to NIM documentation. And we're going through still tutorial part 1. And I don't remember where we finished. We went through iterators, advanced characters. We did over tuples, procedural type, right? Did we go over procedural types? Yeah, I think. Yeah, the thing now we need to go over quickly is modules. It won't be a lot, so we might as well, right? So, modules. NIM supports splitting a program into pieces with a module concept. Each module is its own file. Modules enable information hiding and separate compilation. A module may gain access to the symbols of another module by using the import statement. Only top-level symbols that are marked with an asterisk are exported. Only the top-level symbols. That's the important one, top level. So if you're importing something from some other library, it won't get exported out of this one. You would need to re-export it explicitly. So that's actually something I changed in a commonFs project literally today. So we have an example of what's inside a module A, right? We have a variable. X1 is exported with a star, while Y isn't. We have proc of an asterisk, and it's exported, just to add to the confusion. Okay, so this allocates a new sequence and whatnot, multiply two integer sequences. So basically this is a multiplication for two sequences, okay? And when is main module, so this is like the main executable of the binary. We basically check if we get this times that, and that's it, okay? So this symbol and that symbol, they are exported, and that's it. The above module exports X and the asterisk operator, but not Y. A module's top-level statements are executed at the start of the program. Okay, module's top-level statements are executed at the start of the program. Yes, so basically this gets executed as in we create variables. This gets executed as in we define that there is such thing. And this gets executed, and if it's a main module, it's gonna actually execute that. Okay. Okay. This can be used to initialize complex data structures, for example. Okay. It kind of doesn't happen here, but could be done, right? You write a module that's supposed to manage something. When you import it, it kind of starts up and makes things, things get set up thanks to that. Okay. Cool. So each module has a special magic constant, is main module. That is true if the module is compiled as the main file. This is very useful to embed tests within the module as shown by the above example. Yeah, so when it's a main module, we need to make sure that it works, right? Okay. A symbol of a module can be qualified with the module.symbol syntax. And if a symbol is ambiguous, it must be qualified. A symbol is ambiguous if it is defined in two or more different modules, and both modules are imported by a third one. Okay. So we have module A, okay, and it exports X. We have module B, which also exports X, although this one is integer, not string. And then we have module C that imports both A and B. And when we want to just print it out, it won't work because it doesn't know if it's from A or B, because write can, I guess, print out both of them. Well, here we qualified it with A, so we know that it's from module A.x. Cool. And when we create our own variable and we try to rewrite, now it's not ambiguous because it uses module C's X. This is, I guess, shadowing, right? We shadowed those two. So if here we wanted to print the one from B, we would need to qualify B.x. But this rule does not apply to procedures or iterators. Ooh. Here, the overloading rules apply. Okay, we have module A, which has this, and takes integer, returns a string. Module B takes a string, returns a string. And module C, we have A and B. And here, because we are executing it in those two ways, there are no errors because, of course, with this one, we're calling the string one, which Nim can figure out that, hey, it's this one. Well, if we'll give it integer, it knows if it's this one. if they both would be exactly the same, that takes an integer and returns a string for both, then of course it would make sense. Okay. And so if we define one here, unlike with a variable, it will be like, wait, which one do you mean? This one or the one from A? Okay, makes sense. Good to know that, procs and variables are treated differently. I'd say handy. Alrighty. Excluding symbols. The normal import statement will bring in all exported symbols. These can be limited by naming symbols that should be excluded using the except qualifier. Okay, so we can basically import some module except y. And y is inside the module, right? So we could do import a here except x, so it will import nothing in this case. But hey, it's good to have like imports where you only exclude one. Cool. We have already seen the simple import statement that just imports all exported symbols. An alternative that only imports listed symbols is the from import statement. Okay. So from my module, import x, y, and z. Okay, so this is what you see in Python very often. So we get the module and which symbols from the module to export specifically. And that's what we're using in commonFs in a few areas. I'm using them mostly so that I know exactly where things are coming from. I guess it's not necessary. What I would like to know is that if symbols are not used, will they still be packaged into the binary? That's some question. The from statement can also force namespace qualification on symbols, thereby making symbols available, but needing to be qualified in order to be used. So if we do my module export xyz, and we can use the x, right? But from my module import nil. So we take from module import nothing. And then we need to specify. That's interesting. Cool. I like it. Just import nothing and we can still qualify them that way. So that's good to know. That could be handy to keep things clean in some cases. Since module names are generally long to be descriptive, You can also define a shorter alias to use when qualifying symbols. From my module as m, import nil. But what if I want to do from my module import m as something? Because that will be, I'd say, more useful in my case. I guess you could just define a type, right? Type alias separately. I guess that'll work. That's possible in them. So I have m.x. M is aliasing my module. Excuse me. Okay. And include statement. The include statement does something fundamentally different than importing a module. It merely includes the contents of a file. The include statement is useful to split up a large module into several files. Yeah, include file A, file B, and file C, and they will all end up in a single thing. I just wonder how something like nimsuggest works with those. If it would work, that would be actually really helpful. Because I'll show you what I needed to do in some cases, and here it will be actually really handy. Somewhere I heard that, somewhere I read that include is kind of discouraged, but maybe if you're smart about it and not misuse it, it's still good. It's somewhere in the first tutorial, right? So that's that, and part 2 will be more fun stuff. So let's take a peek. Let's see if there's something short that we could look. Oh wow, we start with pragmas or object-oriented inheritance. Recursive types, type conversions. Oh, whoa, whoa. Let's just read that about pragmas. That one thing, and we'll call it a day with tutorials. Let's not push it. We have plenty of other work to do. Introduction. A repetition renders the ridiculous reasonable. This document is a tutorial for the advanced constructs of the NIM programming language. And note that this document is somewhat obsolete, as the manual contains many more examples of the advanced language features. Yeah, I'm actually personally reading through the manual. It's pretty long, but it's amazing as well. Pragmas. Pragmas are NIM's method to give the compiler additional information or commands without introducing a massive number of new keywords. Okay. Pragmas are enclosed in the special, those curly brackets with dots next to it. Curly dot brackets. This tutorial does not cover pragmas. See the manual or user guide for the description of the available pragmas. What is user guide? Additional features. It doesn't say much. Oh well. Okay, we're using those pragmas here and there, and yep, I believe we can actually write our own pragmas, or like macros can be in the form of a pragma or something. So that could be interesting, very advanced topic to cover at some point. Okay, so that's that. Let's move on to the next topic, which will be commonFs. But what has changed? So let me bring that in. commonFs. That goes away. I'm bringing it here and making it a little bit more massive when it comes to size, okay? So what changed? A lot. If you look on a side here to what we have in our source directory, we have a lot more now, okay? So in our source directory, we have the commonFs, but what we have here is basically a bunch of import and export statements. So I figured that I'm gonna do some cleaning up, because we had our commonFs was, a few hundred lines already, and it was kind of unwieldy to work with. I don't know, I kind of didn't enjoy how much stuff there was. So I figure, hey, let's split it up into something, more logical. So what I did is I made a separate module that just holds errors. And what I'm doing here is that I'm importing it. It's inside the commonFs folder, private, and then we have errors.nim. So I import all those errors here and export all those values, okay? So that whatever imports the commonFs will also import the errors. The same thing with fs, which is just the definition of the file system type. Then we have the directory type. And what I'm doing here, I'm importing it, but exporting only the directory, because I'll get to it. I'll get to why a little bit later. Then we have the same thing with a file type. And then we have file system operations for the directory. Okay, file system directory operations. So these are all the directory related operations that are defined purely on the file system type, like all those main ones, where we have all the methods that we can implement in our implementation library, etc. The same thing for files. Then we have the common operations for directory and file, because there are a few of those methods, so I just put them all in a separate module. And then we have directory operations and file operations. And this suddenly made it a little bit shorter. So if we look at errors, okay, so we go to the commonFs private, and we have errors. Okay. Suddenly, just make it a little bit smaller because a bit ridiculous. So yeah, this is just we define two types which are errors. We can actually get rid of those here. That's not necessary. So that's that. Then we had, what was the next thing? The next thing was file system. So file system suddenly is much smaller. We just defined a type. And I also brought the current directory operations because they don't require anything else and they're directly on the type, the file system. So that's that. Again, I could get rid of those ends, those comments starting here. I don't know where I got it from. Probably ChatGPT thing. Who knows? Next, we have directory. So here, we are importing the FS that we just looked at. And we define the directory type. So that's that. But notice that directory is exported, but its fields aren't. Okay? And because of that, in different areas, let's say in where would it be? I guess file system directory options. Let's do directory operations. Oh, here. So when we define things like, get the name or check if it exists on the directory itself, here we're importing the directory. That means we can't do, directory, which in this case is self dot absolute path, because that's not exported. So I need to make a workaround where I make an exported like private new directory, whatever that I'm exporting, that allows me to get that, that file system, for example. It just returns it and that's it. So I need to kind of make those, and that's ugly. But that allowed me to do something where I just have, hey, that's it. Okay, I'm gonna just, import a private one here because I imported directory. While when exporting it, I export only the tab itself. So all those extra private ones aren't exported, okay? I know it's ugly, right? Just works, but I don't like this solution. So maybe we'll just go back to the ancient times of include rather than import, and we'll still have things separate, but just not super separate, if I'd say so. So that is that, and we have something similar for the file, right? The same concept, those private ones. Then we have file system directory operations. So if we'll go to this one, this is where we have, get directory handle, create directory, the method, the implementation method, and the exported proc, checking if exists, removing a directory, all those basic directory things. And suddenly, there's less code. We can browse through it, right? It's easier. The same thing for file, although for file right now we have a lot more because we have creating files, checking if it exists, removing it, reading the whole thing as a string, reading a buffer as a string, reading a iterator and bytes and writing, and there'll be more. So this is already a candidate for kind of splitting. So I kind of don't like that, I need to import everything here, like errors, file system, file, etc. Kind of makes it messy, especially that I need to do this whole gymnastics here. And same, directory options, file options. Then we have the common ones, which is simply getting the file system because it's defined for both absolute path and parent, because these are all like read-only. At least those two should be read-only. That's why we have a proc that returns the value of the, because directory already has, for example, absolute directory, right? If I'll go to directory, it has the absolute path. But I want it to be only accessible, not like writable to from the outside. So I just made a proc that allows to get that value. So that's in the common one. And then we have just the things that we can perform directly on a directory instance and on a file instance. So I figured maybe before we'll move forward with this whole setup, what if I'm going to just make this whole module a little bit more just made out of a few files rather than this whole crazy, what would you call it? You know, this thing. Because I don't like that. So let's try it. Let's try it because I'm gonna just commit this little thing where we remove the few. Come on, get full screen. This thing where we just remove some of the comments, right? So let's keep that, and we remove weird comments at ends of lines. Over descriptive, but yep, pushed. So that's good. So we've got our code, and now we can try to kind of clean it up again. Okay. So first thing I would do is go to directory and get rid of all those things that we shouldn't have here. Okay. The same thing for file. I don't want that here. Ugly, ugly, ugly. Okay. So we've got that. So what if I'm gonna do it where we have the commonFs, okay? But instead of instead of just having all those little files right next to it, they will still be kept in private directory. Okay, this way nobody can get them directly. You can't import whatever's in the private folder named private. You can't even try to import it from some other module. So that's the good part. So let's see. So I would like to include errors. Okay. And this will be commonFs private errors. Okay. Let's just straight up include that. This way we don't need to re-export that because that's kind of copy paste that file in here. So if we look at that, we have the type this and type that. So that's good. That can stay the way it is. We first define errors. Then I would prefer to do something like include commonFs, and this will be types. Okay. So we're gonna create a new file, types.nym. And what I'm gonna do is go to fsnym, grab that type, and just show it here. And we actually need to do import. Yeah, how do imports work? That's a good one. If I'll save it like that, and do I go in commonFs because I just imported here? What if I'm going to do import standard paths? Okay, I'm gonna save it here. When I go to types, look at that. It's correct. It assumes it's available. Huh. Magic. Okay, that's very good. That makes me very happy. So I can remove it from here because I'm not using it anymore. And all those functions will be defined later, okay? So we've got types. And in types, I would like to also include the directory type, okay? So we go here. The directory type, and we'll also do the file type. Okay. These don't require anything else. They depend on file system, but it's all within one file, so that's good. So I can just straight up delete those two files here. the file, and the dir delete. There we go. And we already have them in this context here. So that makes me very happy. So what else? Then we could, I guess, start bringing in all the methods, like the file system, the current directory operations on the file system. They don't require anything else other than errors and the file system itself. So that's good. So let's just we'll just do that, and we'll just call this whole file something like current directory operations. Okay, let's do fs to the file system current directory operations. Okay, let's have this convention where the first will be what is the thing that we're operating on, like what things are regarding. In this case, it will be file system, and then we have the current directory ops. So let's actually do fs underscore current directory operations. dir current directory options. I'll make shortcuts so that the file names are relatively short but still decipherable. So I should be able to do here include commonFs private, and we have fs underscore current directory operations. Save. And this should be happy now because Nimble knows that this is being linked. Awesome. Okay, this already works so much better. And this whole time I thought that include is a bad idea, and I have a bunch of imports copy pasted everywhere, but well, it takes it from the main file. So unnecessary worry. We don't have that file anymore. Okay, right? fs is gone. So the next thing to do, we don't have those files either, so delete them. Will be file system operations, and file system for directory operations and for file operations. So let's do that. So let's look into directory operations. What do we have here? Let's rename it already. So it's fs underscore directory operations. So if like getting the handle, creating it, checking if it exists, removing it, these are all basic. So I'd say let's keep it here. We don't need to import anything anymore. And also paths don't have to be imported. And we can get rid of those funny little things at the end. Ugh. No idea what they're for. Cool. Okay. This makes me feel good. So we can just import it. So we'll do include commonFs fs directory options. Yeah, and that'll be include, and then we'll have also include this, kind of, but I already have plans for that. But for now, we'll do that. So let's just use some comments to do that. Okay, so it will be, we'll just say that this is base types. Okay, our errors and types. Then we'll have file system operations. Okay. Yeah, let's kind of highlight the file system. And this is on the file system, this is file system, this is file system. And this will be the other ones. So this will be common operations. Let's do directory / file operations, or common, whatever. Let's just say directory and file operations, just on those two types, because we won't have like a million includes, so this already will be good enough. And we'll have this, and we'll have that, and we'll have that, I guess. And it'll be all, oopsie, include. So that'll be that. So we have this directory file. Okay. So let's look at again. Directory options are taken care of. Okay. And then we have file operations. So let's look at that. We'll first rename it. So we have that underscore. And we don't need any imports here. We have all that, right? I already can see that this private here shouldn't be. This will be just fs, and this will be oops, wrong key. I'm still used to JetBrains keyboard shortcuts. So this will be absolute path. Bam. Here. There we go. Let's just get rid of all instances of that. There we go. Cool. So we have that done, and this will be just like that. We just have those methods, and that's it. So underscore, and fs directory options, fs file options, operations. And then we have just a common one. So all those, we don't have to import them anymore. Bam. And I guess we don't need to qualify that either, because we suddenly needed to do it here for who knows why. Clean those up. And wherever we have priv, we don't need that anymore. Okay, cool. That's better. And we just need to rename that some way. Let's just rename it something like commonFs. Okay. And we'll just do here common_ops. And we just need to include options. So let's just import the whole thing here. Import standard options. Now it's happy. Okay, wow. NimSuggest suddenly kind of works. What is going on? Okay. And what next? Directory options. So we rename it to literally directory underscore operations. We don't need all those imports. And all those priv underscore things, they are obsolete already, even though I created them literally today. Then we directory options, and then we have file options again. Rename, add the underscore, get rid of all the imports that we don't need, and get rid of all the underscores, a million of them, save. And it shows that we have errors in here, which is all about that. And save. This needs fs and absolute path, specified like that. Good, now it's happy. And we have some errors here, which are the same thing. Wherever we have file, it doesn't need that in front anymore. Okay, save. And it's happy. Is that really it? That's gonna be just it to make things work nicely. I'll be astounded, because that will be like the quickest refactor ever. So let's see if our refactor worked. File ops are unhappy. Because still we have a bunch of that stuff here. So, bam, save. Oh my goodness, we have a bunch of those. Save. Oh, this code starts to actually look decent. Out of nowhere. Okay, doesn't show any big errors anywhere, so let's try to run the test for the commonFs. And okay, they run. That is surprising. So if that ran, let me show you what actually changed in the tests. Because when we go to the test directory, I add a new test. External. So this is a very short test that, gets the file system from commonFs and also imports all the tests. So this is the import that normally you would use in the whatever is implementing the file system interface if to perform the test on itself. But what we're doing here, we create a new suite for tests and should compile external tests. So all we want is just to make sure that all those tests that we're exporting to actually compile, because normally whenever we were running tests, they were testing some of the basic functionality that's kind of taken out of many other things. But here, if we're gonna include those tests and we're gonna check if this code compiles, that means that if it compiles, that means, we don't have some typos here and there. So this makes me happy, and it just passed. So hey, that's a move forward, right? So now what I'm gonna do is I'm going to simply do nimble dev underscore install. So we're gonna reinstall it now on our local machine, and we can jump to osFs, which is hiding right here. And in the osFs, nothing should change. Everything should work fine, right? No big deal. So let's run the test task. And everything passed. Okay, so looks like we didn't introduce any bugs. Still have this read bytes, read bytes, read bytes. Read string buffered. I need to clean that up. That will be test, right? Tests. Read bytes, and do we have this whole thing somewhere here? Bunch of echoes or something? What was the name of this thing? Should read full contents of a file when starting at 0. Okay. And all the other ones. So this is actually not here. This is in our implementation. Right? Let's just search. Should through error. We want to read string, right? Here, okay. We have this and that. Do we have any? No, we don't have any debugging here. No echoes here. So that means it's in our osFs that we will need to clean up. So in here we have the problematic here somewhere. Read string. Okay, nothing here. Yeah, that's all good. And here we have blah, 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 blah. Debug echo, bytes red. Go away. And then we also have something else here. No, it's just bytes red. And stopping the iterator and some number. So we have that part, and iterator will have starting and debug echo, and another debug echo. And that's it. And we can just condense it a little bit. Okay. So we'll save it. And let's try to rerun everything. Okay, now it's clean without some debug echoes. guess. Read string buffered. We still have somewhere some echoes. Debug echo? No, none. Let me just clear that so that we can have fresh results. Okay, that must have been old ones. Okay, cool. So look at that. We clean things up. We have more commits to do. So first of all, here with commonFs, we're gonna commit all those changes that we just made, which is a lot, but at the same time, it's awesome. It looks so much cleaner. So, refactor, replace, include. We'll replace import with include for increased clarity. Sure. And that works flawlessly. And on the osFs, we can basically make sure that remove unnecessary debug logs. Okay. Or let's call it debug echoes. Okay. Hey, we were just, 20 minutes of that, and we already made so much progress. This is actually pretty exciting. Pretty exciting. I just don't like those. Like, only a ref object can be raised. What the heck? Exception object type acceptn. And sets its message field to message. Acceptn. What the heck? Where did acceptn came from? New exception. Acceptn. Is it a typo? I don't think so, because it's here and everywhere. I don't understand why it's accept n. I guess few bytes less. Okay, so before we can refactor the osFs, let's get back to our commonFs, which looks so much prettier. And look at those little separate files that we have. So we have common operations. This is nice and manageable. Directory operations, awesome. Errors is good. Current directory is good. Directory and file. Here with a file. So we're starting to have a lot for just some simple file. The same thing goes for FS file operations is bad. Normal file operations is kind of manageable because it's calling the other stuff, but soon there'll be way more here. So I was thinking that with the file operations, maybe we should actually split that up into few separate categories. So what do we have here? Get the file handle, create file, check if it exists, remove it. Okay. So let's keep those, or I'm gonna literally cut them out of here. Okay. And I'm gonna make a new file. New file. It'll be fs_file. And this will be commonOps. Okay. .nym. Or basic ops. Just to have all those basic operations here. Okay. Just the basic ones. And we can just go here and make it so that we have include commonFs private file basic ops. Okay. While the other one, let's do read string. Okay. File read string operations. Include. Okay, so we're gonna take this directory operations, and let's rename it to file read string operations. And this way we'll have only read string, read string, read string. And then we have read bytes and stuff. That will go to another one, okay? So let's do cut it out. And let's do commonFs, new file. And not here, here in private. As file read bytes ops.nym. And we just paste it here. And then we have write. So we should have write string. Okay, because this will be string. So we will do new file, fs, file, write string operations. And we'll make one more fs file write bytes operations. And this is where we will take this part here, okay? So we'll have like separate files for sets of those methods. So it'll be a little bit more manageable to work with it. Okay, let's just do it here. File basic read string ops and then write string, but I also want include commonFs private read bytes. Yes, and that'll be write bytes. There we go. And this way we can finish them off at some point. And in theory, there should be ones like for directory and file for that. And maybe I could actually include them there now. It would make sense to categorize things together, right? Instead of having them jumping around. Maybe that's what's gonna happen. Just need a drink. I hate those Pellegrino sparkling natural mineral water. The bottle is so massive, so heavy. It's so difficult to open, you know, unscrew it and screw it back. It's just unwieldy. And it's not sparkling enough. Okay, so yeah, the idea would be so that all the file operations here, we could kind of move away from here. Let's look at this one. The directory options. FS directory operations. We have those few basic ones here, right? We have this and that and whatnot. That's all cool. And creation, check if it exists, and deletion. So these are kind of related. So we also have the directory, just stuff that's being directly on, operations directly on a directory. So directory options, let's just open them on the side. We get things like getting a name, checking if it exists, and removing, okay? So what if things like getting a name shouldn't that be like common for both? So let me check here because we have the common operations. So for common operations, we have getting the file system, absolute path, and parent. Okay, but what about the file operations? Getting a name is a little bit different. That's why. I see. But we still could do it in the common ones. So let's go to common operations, because things like getting file, the FS, the file system, absolute path, and parent, that's fine. Right. So let's grab the name for a file. Okay, we'll just shove it right here. You can actually cut it out of here. The same goes for extension and file name. Okay? Because these are still somewhat simple. Okay, and let's just do it here, and we'll get the one from directory right here. So we'll just make a little section getting names. Let's just do names, etc. And we'll have for the directory, and then for the file, we have the parent that we could actually place after that. Let's do parent. So maybe we'll have something similar at some point, and this same code takes care of directory and the file. And let's do something like paths, and also file system. And let's call it day here, okay? Then we can go to file system directory operations. We have things like getting this thing, creating, okay? Getting handle. I'll put two empty lines between like the whole sections. Like we have here a section of a method and a proc. Here another method and a proc. So here's another method and proc. So we divide it this way. It's a little bit easier to peruse through. So we have create. We don't have equivalent of creation just on a directory, because we already need to kind of have it. Do we? Because we could just get a handle and just ask to create a directory, and then we either get error or not. Yeah, I did that. So let's add a new proc. Proc create. Okay. And this will be on self directory. We don't need provided a name or anything. We just do it, right? And we can just specify if it worked or not. No, we'll just throw an exception if it didn't. So what we can do here is basically creates a directory. It's the directory. Does not, if it exists, there's file with the same name, raises, error, succeeds. The file handle forget, what the heck? So we don't care about succeeding. We basically self, create directory, and it takes an absolute path from itself. Hell, that's awesome. Okay. So yeah, this way we can have everything related to creating directory right here. Okay. That means we need to add a test for that one. Oh. Let me do that while we're at it, because then I'm gonna forget. Tests, create directory, okay? So we just put those away. I'm gonna reduce the font size a little bit. I hope that's not a problem. Okay, so we have test directory path, create directory, okay? and that's the only one that is being tested. So should create a directory using absolute path. Okay. So we have test directory 1 and we test it, and I'm gonna add here let path relative to. Okay. And let's do whatever. Yeah. And then we have absolute the same way. We create a directory, and that's not what we're gonna do. Let directory 2 is file system get directory handle from the absolute path. Okay. And then we do we just make sure it doesn't exist, right? Not directory 2 exists, and then we do directory 2 dot create, and we're gonna check if it exists. And check directory 2 dot absolute path is the same thing. Cool. And this is a type mismatch. Create. What? Directory, get directory handle. So this should, I guess this is just a fluke. Can I run the tests? Yeah, test run. Current directory. Where's create? Oh, I would need to test it somewhere else. Duh. So we go to our commonFs, I mean osFs, and we should be able to just run the tests. Yeah, everything worked. No problem. Create directory. There we go. Absolute path worked. Cool. So we just created here. And we just need to do the similar thing for relative path. So we do let path relative to absolute to. We just get the handle from the relative one. Okay. Make sure it doesn't exist. We create it, make sure it exists, and make sure that the absolute path is correct. Okay. So that's that. And for readability, again, I'm going to put 2 empty lines between. This is the thing with Python, like where indentation matters. Suddenly, you know, if you put empty line somewhere, it's like not a big space. 2 finally makes a big space, and this is where you have language like, you know, C++, C#, whatever. We have those curly brackets. They just add that extra line of spacing, so it's easier to read. And here you need to do double empty lines, huh? It's just white space, no big deal. So that should create directory using absolute path when the current directory is set. So when the current directory is set. Oh yeah, okay. So this is like kind of no big deal. And this is checking everything just fine. Okay. So that's good. We actually don't need to test that part. Or do we? Sure, let's keep testing it. Yeah. Should throw an exception when creating directory with the same file exists. So we'll just do let directory is get the handle for the absolute path. And it should exist. check if it exists, should exist, and then expect catchable error when we try to create it. Okay, cool. And we don't need that here. Should throw an exception when creating a directory that already exists. Should not throw an exception. Oh, it's because it's in file. Okay, I see. So we create directory. So let's do directory is get directory handle and check if it exists, and then we do create, and it still exists. Okay. So that is that. Good. We just updated everything, so that's awesome. Let's see if it compiles. It compiles. Let's rebuild it, go to osFs and test it here. Error. Okay. Let's clear that out and let's run it again and see where the error is. Here. Failed. Should create a directory using an absolute path when the current directory is set. Huh. Absolute path when the current directory is set. Okay. So permission denied. Okay, that's new. What the heck? Huh. Well, it's a fast 21. But let's see if our test is just wonky. Use absolute path when current directory is set. When current directory is set here. So we have this path, okay. Absolute path, all that. Created directory. And we check if everything's fine. Here we have the same thing, we just add another subdirectory in here. Okay. Yeah, and it worked here. We get a handle to it. And we try to create it. Why would it suddenly not be happy about it? When the current directory is set. We don't have it even set anywhere here. What the heck? It's not set. So we do current directory is test directory path or something, right? And now should be more accurate. Wow, we're finding pretty big errors already. But I don't know why it says suddenly access no permission. It can't create within directories that it already created itself. That would be surprising because I think we already did those things. So go figure. Okay, so let's build it and get back here. And what is the problem suddenly? Suddenly all tests passed. So I guess it's a fluke with, again, file systems. That's the one thing I don't like. Let's actually add something to those tests. Oh, I will need to add that to every damn test. Let's avoid it now, at least for now. Okay, so we're done with the create directory. Okay, and let me just see and hear what we actually changed. commonFs. Oh, we did all that. Split the operations. Yeah, let's continue with this here. So directory operations, we'll be able to, again, move them away, right? Because we just added the create here. Directory exists. We have this and that, and we should be able to grab that from here and just move it here. Okay. Bam. Everything should be still fine. Save. And the same thing goes to remove. We can just put it right next to other removes instead of having that big split. And that means we can remove the directory ops, which is here. Delete. Yes. Excuse me. Means we can go here and directory ops go away. What's in common? Do we use any special file system stuff here? Common ops. No, nothing special here. Nothing here. Nothing special here. Nor, and I know those. This only is get directory handle. Bootstrap them. So those handles where they are defined here. I see. I guess they can be after that, right? Yeah, that's good enough. Yeah, I was just thinking if I could take those and move them somewhere up before the file system operations, but I guess we need the file system operations in place before we do specific for those. So let's move to file ops here. And oh, I will probably need to, let's also keep the reference to directory ops, and we can do file. Wait, not that. Oh, we split it out everywhere. Basic ops. File basic ops. Get file handle, and then we have create. So I guess we should be able to do the whole thing just like we did here with create, right? Proc create, and will be self as file. And this will be because empty file and the path of the file handle does not raise anything that already exists. Okay. That'll be fs. This will be just create file. And that's it. That should be it. And that means I need to go and redo them tests for creating file. No. Oh, I hate that part. That path. Relative 2. Okay, let's do this will collide with that one. 1B. So this will be 1A. Let's do here. 1, 2. Okay, just 2 instances of that. So it'll be 1A. And this here will be 1A. 1B is this, and we do 1B, and then we do var. Will be. Yeah, why do I even bother with those when I can make them vars? This is no big deal. I'm making my life way too difficult. Var. Let's do path relative. That'll be file 1b. Absolute is just that again. And file is fs.get file handle. And what else were we doing? We were checking if the file exists, right? No, first we need to call create. So file.create. Okay. And we just check if it exists. Check file.exists. And yeah, now it's unhappy because it doesn't realize that create exists yet. Okay. So let's just call it a day. And we'll do the same thing here where there'll be all vars. And we do path relative is to b. Yep. And current directory is already, it'll be here, okay. And file is get the handle, create, and check if it exists. Okay, that's good enough. Should throw an error if the directory of the same name exists. So it'll be var. So now we do let file is fs get file handle path absolute. And I don't need those as var. They could be lets, no problem, right? We just get the file and we do expect catchable error. File create. Yeah, it should throw an error. Okay. Let's make sure we have those double empty lines here as well. Just two more to take care of. Should not throw an error if a file with the same name exists. Okay. So do var file, and here we do file is get file handle, create, and we should make sure it exists. Okay. Last one should throw an error if parent directory does not exist. Okay, so we have this and that, and missing is missing. So we can do the same thing here where we have let file get a handle and create should throw an error. Awesome. This is redone. Cool. Let's run the local test. If everything goes well, everything went well. Let's rebuild it. Let's go to osFs, and let's rerun the test tasks. All good. Okay. So I hope we won't have to touch tests for a while now. I really hope. So we've got the basic ops. We added the create. Now we can move the exists. Okay. We already have that tested. And the remove. Okay, all the basic ones are done. So that is good. And next one will be to do read string. And here we have only one defined, so we'll need to define the other ones. Really need to figure out how to do the testing better with all those variants. So let's go to file read string operations. Okay. first one is read string all. So this is basically reads the content of a file or as a string. Okay, so that will be it. So we have this, and that, and we just have it here. Okay. Then we have the second one, ring string buffer implementation. So this is where we need to add it. Proc read string. Okay. And self is file. And we need to provide it with a buffer and start and length and return integer. Okay. All the same stuff. And to specify blah, blah, blah. And we just relay this thing just by giving an extra absolute path. Okay. So that's that. And I'll just need to do test. Okay. I won't be doing that now on a stream. It's just a little bit too much. So that was that. And we need one more. The iterator. So that returns it, right? So we do iterator. Get string buffered iterator. No, read string buffered. And it'll be on a file, so we don't need the path. Buffer by buffer. And it's an iterator. Okay. So suddenly this shouldn't be like this. We should be calling the iterator here, right? So we should be doing basically for infs dot read string buffer, then we provide it with absolute path and the other stuff. Okay. Yield I and it'll be self.fs. Okay, that should be it. There we go. We'll reuse everything. And again, to do test. So that's that. Good. Now we can go to bytes. So read bytes. I have a similar story here where we have read bytes and it's the whole thing. So we just grab it and place it here. And we need to add implementation here for reading bytes. I mean, buffer of bytes. So just give a file instead of path. We have all that. Gonna file into specified byte buffer, specified index. Yeah, and we just return it. Okay, that's good. And I already know that here we need to define something like we had previously with the read string, because I want that to exist and be like with a string we have read everything to one string, read just a part of the file into a string, or give me the whole iterator to iterate over chunks of a string. And here we have read everything as bytes, read into just chunk of it into a byte buffer. And now I want the third one, which will be read the whole thing. So let's define type, bytes, buffer, the iterator. Okay. So we have iterator, buffer, and this will be var open array byte, I presume. And we won't need to provide that. And that returns integer. Okay. Therefore, we can do method get bytes buffered iterator implementation will be self file system. Next will be just grab this whole thing, okay. And it'll be open array of byte. And will be bytes buffer iterator as a return type. Raises all those things the same way. And yep, that's it. So the next one will be this thing. I'm just gonna straight up copy it and just replace the thing with bytes buffered, blah, 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 open array of byte. Yep. And it reads the contents of the file buffer by buffer. Number of bytes read while that is available in the buffer. Blah, blah, blah. Do that. Iterator will be get bytes buffered iterator implementation. We give it all that and we just iterate over it. And that's it. And the last one, to do tests, we actually have to copy it for both. That one hasn't been implemented either. Bytes. Open array of bytes. Blah, blah, blah. Bytes. And that's it. So we'll have those to test at some point and actually implement. So that's that, but I want to go over that right now because, you know, on the stream it will be just so boring. Well, this will be mostly copy-paste implementation, just small differences and whatnot. It will be actually simpler because we're reading already into bytes and now we'll be changing things up. So that's that. And inside the file ops, we have only one thing, write. So write, and this is a string. So we just grab it here and cut it out here and shove it here. And we've got the same thing. Yeah. And we can get rid of file ops. Delete. There we go. And that means we have write bytes. That should be relatively the same. We just have open array of byte instead. To file. And if the file doesn't exist, will be created. Okay. Yeah. Makes sense. And that needs to be again to do test. So I have some of those. So that means that inside the commonFs, we don't have that one here either. And I think instead of having this fs everywhere, because now we kind of combine multiple things at the same time, I'm gonna get rid of that. And I'm gonna get rid of that as well. Okay. And that means I need to rename everything and remove those little things. But the good thing is everything kind of gets simplified. Let's actually do directory underscore options. And here will be file underscore basic operations. So all the file related stuff will be there and whatnot. Okay. And that means I should also make those lowercase. Renaming files is so tedious. Only they were just a text file. I'm sure I could do something like that with what do they call it? Vim or NeoVim or something. But that's a territory that's scary for me. Okay, so in that case, directory basic ops, and this one will have the fs current directory ops. Okay, so we can do a little bit here. Fs current directory ops. This will be directory basic ops, and here where we start everything with file, we'll just do file underscore, and I don't know how to make this lowercase. B-R-R-W and W. Save. This one exists. Basic ops. Oh, lowercase b. Now we're good. Oh, gosh, it gets simpler and simpler. Easier and easier to read. Okay, so let's do that. Let's do this thing as directory. Will be file system operations, directory operations, and we'll just have it as file operation. Let's do common operations. There we go. Let's test if everything still works. Still works. Good. So that means I can rebuild it and go here and hope for the best when I test it. All worked. Wow. This is awesome. So let's commit all the million changes again. Refactor. Directory structure. Whatever. Project structure. Further. Okay. Add missing there and file operations. Push it. There we go. osFs stays the same. So if that worked here, I can just go on and kind of refactor the osFs as well, right? Because we have the bunch of stuff here. Like all the implementations for writing and reading and all that. So if we'll take an example from here, I could literally do this. Copy and just show it somewhere up here, okay? Bam. And let's get inspired. So we have this, we get stuff from directory, and yeah, files, commonFs, and all that. Cool. So what I'm gonna do is actually I'll import commonFs here, okay? And the rest will be imported case by case. I'll try to do that instead. No, let's keep to the way it was. Okay, commonFs on the bottom, all the standard stuff here. All right. Makes sense. So base types, we don't need those. Current directory options, they don't exist here because they were implemented there. And then we have basic directory operations, okay? So first of all the commonFs / will be osFs. Okay, so we can create a new folder, osFs, and there we can create a new private, directory, private, and in there we can basically make, do we implement nothing basic here? Create directory exists, yeah, okay. So it'll be directory basic ops.nym. And what we will have here, we actually have the type here, right? So let's do that. Straight up here. Bam, the type. We don't need anything else yet. And we can define new osFs on top of that. Okay. That's good. So then we have create directory implementation, exists implementation, remove. Okay. So these are all the basics for the directory. So we just go here, plop them here, and make sure there are 2 spaces in between. And yes, that is correct. So also first nym, this should be fine. Although it doesn't like some stuff, but I guess we'll get over that soon. File basic ops. File basic ops.nym. And this one will have all the file. Create file. File exists. Remove file. And that's it. So we just plop it here. Save it. Okay, everything's spaced nicely. Cool. Next, read string options. Okay. File. Gosh, I can't type. File. Read string operations. And let's just copy it and we'll just name it. Next one will be. Seriously, I can't rename one file while the other one is selected. What a stupid piece of software. Read bytes operations. Write string operations. And write file. Wait, file write bytes operations. Okay, so you have those pre-made. Get my osFs nym. Common operations. I don't think they will be here. So here, read string all. Buffer, and here we have the iterator. Okay, so we've got those 3. This is all for strings. So read string operations and bam, done. And next, we have read bytes implementation. Okay. Read bytes, bam, save. And this will need the additional ones to be defined here. And then we have the write string, okay. So common operations aren't defined here. Save, write string, bam. And bytes are empty for now, okay. So we've got all those. This seems to be somewhat happy. Unidentified file system. Well, it should take it from here. And all that, it should be fine. So let me try to run test tasks. All passed, all is good. Okay. So not too bad. It worked. It's just lots of red stuff right now at least, but not for long. Good. So I can just, wow, was so much faster. Okay. Let's commit it. Bam, 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 bam. And bam. Split main file into smaller, include smaller files. Okay. Comment the changes, push it. Awesome. Yep. And come on. Go away. All right. Yeah. I'm satisfied. So if we cleaned it all up so fast, I can finish the commonFs implementations and probably tests more like that. Hopefully it's gonna go relatively fast. So let's see, read string operations. We need to add tests of this. So we read string tests somewhere there. Test, read string. Okay. And double click. Jeez. When you open a file, keep it open. Where was I? Read string operations. So the read string all is fine. Buffered, we need to add tests of the one that's on the file. So in our operation here, here, test. So should read that, right? Full contents. We have this tested, and we also have it tested for the thing. Okay, so read string all. Oh, I can't fold it, too bad. And there's another suite. Implement read string buffer. So that's where you need to add the one where we can just call it on a file. Should fill entire buffer from start position 0. Okay. So we have the path, right? And the text. And we create the file. And we say that the buffer is 10. Okay. And we just do it here for that thing. Okay, so we can do buffer is, we get a new buffer, and we do let file is get file handle from the path, and we just do file read string. Okay. And we just call it with buffer 0 and buffer length. So we want it to be var. And we just check buffer is the same and read is the same. Alrighty. That was test number 1. Let me again add the spacing because this one here lacks it. Also be a little bit longer, but I can live with that. Okay, that was test number 1. Now test number 2 we need to modify. We did that and that and that, and we start again. Variable. So buffer new file and read from the file, and those two need to be the same. Bam, that was fast. This is exactly where something like Copilot works so well, because, you know, instead of you paying attention to those little things, you can just tab through it and you're gonna get done a little bit faster. Okay. So we just follow the same damn pattern. Okay. Partially fill buffer from, yep. Okay. And that's correct. Cool. Empty when reading empty file. Okay. Buffer file, read it, and expectations. Cool. Make buffer empty where no data left. This will be a bar. Oh, I have plenty of tests here. Holy moly. It looks like it took a long time to write. Probably did. I remember being so upset about it. How many more? Jeez. And we had this thing here. Variable as well. Mm-hmm. Okay, that's correct. And here we're just doing... let's also do... Yeah, buffer doesn't matter, right? File is here. And should throw an error if we'll just call it from the file. Okay. Error path points to a directory. Okay, so we've got that. And we've got our buffer. That means the buffer here could go up. Uh-huh. Okay, so that's it. Let's put 3 of them here, and this will be this one here. Let's actually make, again, nice comment. Iterator. Well, this one here is gonna be buffer. And this will be all. And the iterator is just one test. Oh no, I need to copy them all? Seriously? So should read full contents of a file when starting at 0, right? Yeah. I see. We have our buffer, the end result. Okay. So I should do buffers. Okay. Yeah. So let's do constant buffer length is 10. We just show that this is all buffer length. Okay. So buffer didn't even get created. So we'll just create a new buffer as a just empty string. Okay. And result is empty string. We get the file. Now for characters, read and file dot blah blah blah. We just check for those. And at the end, we just check for the end result. Okay. Sure. So we can actually go here and we have this one tested, right? Let's actually run those tests to oh, we can run the tests properly because then the osFs will be just unhappy. That needs no osFs for that one will be happy because it doesn't require any new implementation. That's it. So I can just, what is this doing here? Go away. osFs. Oh wait, I need to compile this one. Dev install. That's it. And now run the tests. We have more tests, but they all passed, so that's good. Very good. Okay. And then the last thing will be to perform all the tests for the buffered iterator, including this one. So, yeah, that's fun. But we have it implemented, right? The string buffered. So, it shouldn't be too much of a problem, okay? The thing is that that's a long test. But what should we worry about? It should read full contents when starting at 0, right? And we're not doing this weird stuff with buffered. So from 0 is fine. Should fill entire buffer from start position to 15. We don't care about that. Should partially fill buffer? No. No partially stuff. Should make butter if should make buffer empty when reading empty file. So yeah, okay. Read file. So next test will be, or the one of the tests will be, should return. I mean, should read nothing when empty file. Okay. It'll be that. And right now I'll just spread this card. Then will be should read full content of the file when starting at 15. So read partial contents of a file when starting at 15. We'll just move it up a little bit. Okay. So starting at the beginning, middle, empty file, and also we want end of the file. So tests should read should read full contents of a file when buffer is larger than a file. Yes, I want to test that too. That's a good one. So we'll actually move it up here and come on. Should read nothing when starting past file end. There we go. And then what were the errors that we could expect? Should throw error if file does not exist. Okay. And one more. Should throw error if path points to a directory. Okay. There we go. So we have 1, 2, 3, 6 tests to write. Oh. That's not something that makes me smile. Okay. Let's try to use ChatGPT. Bam. Boop. Let's go here. I'm writing tests for my NIM library. Here's the yeah. Here is the implementation. Okay. We'll put implementation. And here are my existing tests. Please write me a following test. And we'll just give it this thing. Please respond only with the contents of the test. Don't print out rest of the file. Okay, it's just so we have something saying. So we can put all the tests. We'll get rid of all the discards for now. Okay. I'll just copy the thing that I want, what I want the test to be. Okay. Got that. And write me a following test. We paste it here. And I just want the actual implementation that we're using. Because this is about this and that and that. Okay. This way it has enough context about everything, and from there we should just take it. Let's see if we're gonna get anything. Copy, we're gonna paste it and see what happens. Okay, just need to fix some misalignment issues. File and buffer is larger than file. Okay. Is the buffer larger than file? Text short content. File. Yeah, we create a file, so that's all pretty much the same. Buffer length will be just nice. And we just create new buffer. We read the stuff. Okay. But that's not it. Because I see. So let's undo a little bit. Okay. And let's actually copy this part in. And let's edit our requests. Where's the edit button? Come on. Top, really? So we've got the thing here. This is buffer. And then we've got the iterator here, where we want to just add those. How about paste it somewhere, right? How many should be here? Test. Copy. Paste. Okay. Please write me the following test for iterator variant. Okay, and we've got this thing. Send. Now we should get the correct one. This directory, large buffer, and now it does go through the whole for each thing. Okay. Cool. So greater chance that something's gonna work now. We just plop it here. And yeah, so let's see. The large buffer, shortfall content, and we just create a gigantic buffer. And string characters, everything, just read through them, and the result should be the whole text. Okay. Okay. Cool. And the same thing goes here. It just uses the file.readStringBuffer. Great. Now let's move forward and implement the test. Also for iterator. All of tests that I'm going to ask for will be regarding the iterator parent. Okay, so we can save ourselves some stuff. So now we just get another one. I really like where I don't have to think too much. And let's paste it and see what happens. The same thing, partial starts 15. Excuse me. Yep. 10. 3 partial contents of a file and starting at 15. Okay. Mm-hmm. And the row will be test from 15th up. Oh, that's a smart way to just check that. Cool. And now this, please. Okay. So past file end, length, start position, and we're just gonna move it around, and they all should be end result 0 and buffer length 0 and whatnot. That's awesome. You're doing great. Now, okay, should read nothing when empty file. Okay. Oh, now they only have bad response. They don't have a good response anymore. Huh. Interesting. And it can read aloud in here too. Very interesting. And I can't hear anything. Oh well. You have the path here. And let's get back here. Should read nothing but an empty file. So this will be empty file. We write nothing to it. Okay, is it correct when we write nothing? We had something similar. Empty file. Make buffer empty when no data left in the file. Empty file. Yeah, I guess I can just write it like that. Cool. Buffer length. Blah, blah, blah. Read string buffered. It should be empty. Okay. Should throw error if file does not exist. Okay. And we just copy the damn thing. Existing file. Expect error here and file here. Yep. And the last one will be, yeah, it tests the errors for loops nicely. And the last one. Okay. It just throws in, oh, let's do relative this time and all that stuff. Pause to the directory. Okay, cool. Very cool. So I saved it. Let's just make sure it compiles. It does seem to compile. So let's actually build it. And osFs should handle that because this was implemented, right? So I'll run tests. Oh, it just worked. And, read string buffered for iterator. All the tests went okay. So let's do one more thing. Awesome work. Am I missing some important tests here? We've got comprehensive, buffer size larger than content with offset. Non-zero, start with full buffer. Show the functionality when starting to read from a non-zero position, but the buffer size is exactly remaining oh yeah, these are good points. Reading with different buffer sizes. Right, including very small, one character, and large buffers. So should read partial. All that. These are tests. Ensure functionality handles various edge cases and different buffer sizes. So this is Orphan 4. Let's copy them and paste them. Let's see what happens. So if we can get just a few extra tests for free, hey, I'm all for it. So what will we just paste? Should read partial contents when buffer size is larger than remaining content. Okay, we have this thing, and we start at 15. Cool. And yep. And then we have should read full contents when exact remaining buffer size from non-zero to start. So we should start with some kind of buffer that already has the text. What's the problem here? Cannot evaluate at compile time. Text. Constant. There we go. Start position. And then we just do all those. Okay. Okay. Sure, we'll try it and should read varying buffer size correctly. And it's just, look at that, goes for all the stuff and just tests it. Hell yeah. Just make sure it compiles. Does, let's install it and we can go to the, not this, what the heck? osFs. Run those tests. Yeah. It's all happy. Extra number of tests. Wow, I'm impressed, ChatGPT. Maybe it's the new one, new GPT for Omni. That's a little bit better. I heard it's a little bit better with coding tasks. So let's go to commonFs and let's do read. Yeah, we did the buffer and everything. So we remove those here and we'll be implement remaining tests for read string operations. And let's push it. Okay, and what else did we have? Not here, but this will be read string ops, and this will be read bytes. This is tests, and then we have read bytes operations, and we have this one. And then we need all this, and this will be all another massive headache of tests. Oh. Hey, if someone wants to help out, please help out. Please write some tests for me. Okay, but yeah, with GPT, I think I can kind of do it. I can give it, hey, this is what I was testing here without implementation, and here there's the new implementation. Make similar stuff. Okay. I think I can do it. So that'll be it for now. It's kind of late here, so thank you for watching. And remember, please like and subscribe on YouTube if you like my content. And now after the stream will be done, feel free to, write in the comments if you have any questions, suggestions, or something. Links to both commonFs and osFs on GitHub are in the video description. So, you can easily follow. And if you're watching on Twitch, consider following. And that'll be all from me. I'll be streaming most likely for sure on Friday. We'll see if I'll stream anything tomorrow, but that probably won't be commonFs, it'll be something else NIM related. Possibly, maybe not, we'll see. Again, thank you for watching, and see you next time, I hope.